In today's video, we're going to be solving systems of equations using substitution. So remember, a system of equations is two or more equations, and you can solve them in many different ways. One way is we learned is graphing. Another way is using substitution. All right. So substitution, remember, think of like in a sports game when you have a substitution, one person comes out of the game and another person comes in the game. The same concept goes with mathematics, where a variable is being replaced by another term. All right, so let's take a look at the first system right here. Notice both of these are in slope-intercept form, which is a really good thing. So when we're looking at these problems, we're trying to see which variables are isolated. And in this problem, both of these variables are isolated. The y's are both isolated. So what we do is, once we've determined which one is isolated, since they are both isolated, what we'll do is we take one of the isolated ones, which I'm going to take this bottom one right here and substitute it into the top equation and combine those two equations into one. So that's the whole goal of doing these systems, is to take two equations and make them into one equation that you can solve with just one variable. So this y comes out and the x plus 2 goes in for that y to make it into one equation. So my new equation is going to be x plus 2 equals negative 2x minus 4. One equation with only one variable. All right. So I draw my line down the equal sign. And I'm just going to put a little 1 out here just to help me remember how to solve that equation. And what I'm going to do, there's different ways you can solve this equation. What I'm going to do is I'm going to bring all the x's to one side first. So I'm going to bring this negative 2 over this side. In order to do that, I have to do the inverse operation, add 2x to both sides. And then I get 3x plus 2 equals, those cancel, negative 4. Now it becomes a two-step equation, minus 2 from both sides. So we get 3x equals negative 6. Divide both sides by 3. And we get x is negative 2. Now, usually when we solve equation, that's like when we get the variable by itself, we're done, right? But remember, with systems, we have to also solve for the y value, okay? Because when you're solving systems, and we did this graphically, it's basically we're seeing where two lines intersect. So we need the coordinates. So we have the x value of the coordinates. Now we need the y value. So what we do is you can plug this in into either one of these, since the y is both isolated, and you should get the same y value, right? So if, say, let's plug it in to, I'm going to do the bottom one since that's easier, right? I'm going to plug that back in. So y is going to equal negative 2 plus 2, which y is going to be 0. And it should also work if you did it up on the top one, right? So if I plugged it into this one right here, you would get y is negative 2 times negative 2 minus 4, which is positive 4 minus 4, which is 0. So doesn't matter whether you plug it into the bottom one or the top one, right? You both get the same answer. Y is 0. So the answer to my system, the point of intersection of my system, the solution is negative 2, right? -2, 0. -2, 0. Make sure you put parentheses and you put the comma in between to make sure it's coordinates, right? Because this is your x, this is your y value. So this is your solution at the very end. All right. So it's basically, if you know how to solve an equation with one variable, you should be able to do these. The only difference is we're just using substitution. All right, let's take a look at another one. Move this over here. All right, so which one, we take a look, which variable is isolated? Right here, the x is isolated. So we're going to take what's here and substitute it into the x of the other equation. Ah, disappeared. There we go. So I'm going to take this -2y and substitute it into that x right there. Now, whenever I substitute, I try to put parentheses around it, right? So when I substitute that in, you do -8 with parentheses, -2y. I'm going to do this in a different color, right? So if I'm going to make this red here, I'm going to make this -2y. All right, and then finish it off. -y equals 30. Draw a line down the equal sign. And now I solve this. We have one equation now, right? -8 times -2y is +16. Y minus y, right? -1y, if you want to put that 1 out in front, equals 30. 16y minus 1y is 15y. Combine like terms. All right? You have to combine like terms. Divide both sides by 15. And my y value is +2. Okay. So I have my y value. We're not done. We have to find the x value of my coordinate. So we have to take this y, and I would put in this bottom one because the x is already isolated. So you just got to plug in y in here. So you take that and you plug it in. And so -2 times +2 equals x, and -2 times +2 is -4. That's my x value. So my solution is going to be 2. Nope, careful. The x value comes first, right? X is -4, so it's going to be -4, 2. Right? Always, again, make sure the x value starts and then the y value is the second part of your ordered pair. And there is my solution. And also you could double check, right? -8 times -4 is +32. -2 is 30. All right. It's another way you can check. All right, let's look at one more. Ooh, got one with parentheses. Okay. Not a big deal. Now, when we see parentheses, okay, we always think in our heads, first thing we do is we distribute this term to everything inside the parentheses. We want to simplify as much as possible, okay? We take a look at this system. This is the one that's isolated. The y value is isolated. So this is going to plug into the y value of the other one. But to simplify, I want to distribute first. So I'm going to distribute. and I get negative 3y. Let me give you some room up here. I'm going to write it above. So you have negative 3x. Negative 3x, right? Negative 3 times negative x is negative 3x. 3 times 1 is positive 3. That's my y. Okay, so I don't need this equation anymore, right? After I distribute it. So again, this y is isolated. So I'm going to take this and plug it into the y down here. So you're taking that and plugging it into the y down there. So you have negative x, which I'm just going to write as negative 1x, plus 3, parentheses, don't forget the parentheses, negative 3x plus 3, equals 29. All right, so you took this, and you substituted in the y down here. Let me give myself some more room here. All right. We got an equal sign. We're going to draw a line down the equal sign. We have another set of parentheses here, so we have to distribute this 3 to both terms. No calculator. All right, so we're going to distribute the 3 here, right? 3 times negative 3 is negative 9x. 3 times 3 is 9. Bring down the negative 1x equals 29. Take a look. We can simplify our equation. Negative 1x minus 9x is negative 10x. Right? So if we combine those like terms, you get negative 10x. Bring down the plus 9 equals 29. Minus 9 from both sides. And you get negative 10x. Those will cancel. Negative 10x is 20. Divide both sides by negative 10. And you get my answer is negative 2. All right, I found the x. What do I have to find else in the problem? The y value. So I found the x. Now I'm going to find the y. I'm going to take the isolated one up here, right? I'm going to plug in this negative 2 all the way. Let me see if I can zoom out. Oh, I can zoom out. Look at that. Fancy. All right. So I'm going to take this negative 2 and plug it all the way back in up here to find my y, right? So we have negative 3 times negative 2 plus 3. That's equal to y. Right? Negative 3 times negative 2 is positive 6 plus 3 equals y. And my y is 9. All right. And then again, you can take this. All right. You could also put it in the calculator, right? That's what I wanted to show you. Negative 3 times negative 2 plus 3. So negative 3 times negative 2 in parentheses plus 3 is 9. Okay. Maybe a little quicker, simpler, easier to type it in once you found one of the values in the coordinates to plug it back into the other one. All right. So, all right, back to this. All right. So my answer then, my solution is negative 2, positive 9. Always remember x, y, right? This is the y value. This is the x value. And we type that in as our solution because they are coordinates. All right. So that's it for today's video. Thank you for watching. And remember, whether you're solving for x or y, always give math a try.